Probably the biggest pain point in C++ is compile time. It's a very powerful language, but it can be slow to build. There's a famous XKCD comic about compile speeds that some of you may have seen before, which makes a joke of it. While you're compiling, you might not have much to do, thus sword fights on office chairs. But it's not really a joke because it can be a productivity issue. It's useful to have a fast compile debug cycle so you don't lose your focus or thoughts while trying to solve problems. Or fast builds may allow you to have a better CI setup. We've had a few solutions to this. Compile, which is a great tool and works with bcc64x. CMake and Ninja, as we just spoke about, which is really better or intended for using with third-party libraries because it's what they come with. And in the past, batch compilation with the --jobs parameter. This one sends all the C++ files to the compiler in one go, i.e. batches, and used multiple processors at once, which was jobs. In 12.2 we've brought that back, but it's a completely new implementation. The new batch compilation with jobs is faster than the old version, and it's on by default. This means that just by installing 12.2, next time you compile, you'll get an immediate speed up. No configuration, no settings, no changes, just install 12.2 and it's faster. And it will roughly scale with the number of cores and amount of RAM your machine has. But how much faster? We ran some benchmarks on some synthetic code where we created 5,000 files containing 360,000 lines of code. And we measured compiling this against the classic compiler, Visual C++ with Ninja and with its own version of multiprocessing, our toolchain with Ninja, and the new default. First, classic is very fast. That's because it does far less, the compiler is far simpler, and the STL available for it is far simpler. And while we strongly encourage you to move away from classic, we know people still use it because of its compile speed, so it's important to have on this kind of chart. Let's look at Visual C++ used with Ninja, Ninja being the industry standard parallel compilation tool. It takes a bit under 30 seconds. Then let's look at Visual C++ with the /mp flag. This is Microsoft's own version of our --jobs, and shows what may be the best case scenario for Visual C++. It's a lot faster than with Ninja. Now let's look at our new compiler, bcc64x. First, let's look with Ninja. It's faster than Microsoft Visual C++, which is unexpected. We don't currently know why that is, and maybe it's just this codebase. But it's already looking pretty good. Finally, you might detect a trend on the times here where smaller is better, and you can see a direction we're going. So let's look at what we get with the new compiler using our new batch compilation and jobs. Wow! Now this speeds up based on how much it can parallelize, which means you need CPU cores and memory. We tested on a beefy machine, and you can see its hardware on the slide, over a dozen cores and 64 gigs of RAM. But we think it's fair to say that you should get performance improvements over the default compilation by upgrading to 12.2, and we certainly recommend installing it and trying it out. Now, we are still benchmarking. That was synthetic generated code, and we found while I was writing this presentation that code using the STL was slower. And that may be to do with libc++ having many individual files and what are called transitive includes, which is where you include something that includes something that includes something. Or other indications are that it depends on the C++ version you target, especially when comparing against different toolchains. So at this stage, we're still benchmarking and testing, and it is likely that you will not get results completely matching the first benchmark we did with your genuine real-world code. Now that particular benchmark showed that we are faster than other modern toolchains, but other benchmarks are different and we're analyzing that. What we can say is that in some measurements, as you saw, we are faster than the other comparable toolchains we've tested against. What matters is really the performance improvement for your projects. And just because we have this feature on by default, you should see compile times improve by default just by installing and using 12.2. Plus, this effect will be more visible the more files you have, i.e. the larger your project, the more this will be visible, matched with having more cores and RAM.